Hello and welcome to the lecture series of computer organization. Today we will start with a brief history of computers, and it is also sometimes called as generations of computers that we will see. The evolution of computers has been basically characterized by increasing processing speed, decreasing component size, increasing memory size, and increasing I/O capacity, and obviously speed also. So depending on those improvements, the generations were classified. So we will see one by one. So initially, when the evolution of computers started, two names are very important. First one is Babbage, that is Charles Babbage. Babbage was one of the mathematician who came up with analytical engine in 1940s, which was able to do basic addition and subtractions. And one more name we can recall is Blaise Pascal. Okay. So these are the two different mathematicians who came across actually how the computer can be evolved and how it is helpful for calculations, doing mathematical calculations. Okay, so those are the two important mathematicians. So Charles Babbage is also called as father of computers because he was one of the person who came with the mechanical implementation of a computer at the start. All right, so let's move on further. The first generation. The first generation was from 1946 to 1957 basically. The first generation widely known with the general purpose computer called as ENIAC, that is electronic numerical integrator and calculator. Okay, so it was basically made up of vacuum tubes. The concept was based on John von Neumann. In upcoming lectures we will see the architecture of John von Neumann, using which the stored program concept was introduced, where the users will be able to store the program that is needed to be executed on the computers. Okay, so still in our latest computers we are using that concept, right? There were machine core memories and magnetic tapes are involved in storage purpose during that first generation. So we will see that. You can see on the slide the diagrams are shown. The first diagram shows a diagram of a picture of a vacuum tube. So vacuum tubes were basically introduced in order to store data, and this is what the collection of vacuum tubes looks like. And whatever the inputs are provided to the machine or the first generation computers, what those are provided in the format of punch cards. Okay, so these are punch cards based on which we are providing input and we are receiving the output from the system. Okay, so each punch card pattern, each punching pattern represents one decimal value. Remember that in first generation the binary language was not introduced yet, so the punch holes represent a decimal value from 0 to 9, having each unique pattern using which the machine used to identify that. Another system which was introduced in first generation was ENIAC, that is Electronic Numerical Integrator and Calculator, in 1943. It started evolving, and in 1946 it finished, or they have completed the implementation of ENIAC. It is also one of the general purpose computer that was introduced. It was having 30 tons of weight, and near about 18,000 vacuum tubes were introduced. And again same storage program concept was implemented, and it has a set of electronic memories called as accumulators, where the intermediate processing data was stored. Okay, you can see in the diagram or the images of the ENIAC, there is a lot of wiring and the system is introduced. If you if you want to tell me the size factor of first generation, the size was tremendously big of the computer as compared to today's size. Each of the module of the computers would take near about one floor of entire facility. So I can say that at one floor I'm using a storage unit, and at one floor I'm using a processor unit, and at the third floor I'm using a control unit. So I need near about 3 floors in order to store the computer in the matter of size. So it was very big, it was huge, and it used to generate a lot of heat also. Okay, so another computer of that category is ADVAC, that is Electronic Discrete Variable Computer. So they have introduced a little bit of instruction set inside this computer variant other than the earlier one. So actual store program concept is introduced. Stored program concept enables a program to modify its own instructions. So the user was able to change the program whenever necessary. The instruction format was like in the format of A1, A2, A3, A4, and opcode means I can provide 4 operands or values on which I need a calculation to do, and what kind of calculation I need to do I can provide on the opcode value. So it can be like I can use A1 and A2 and A3 to do the addition instruction or addition functionality and store the results in A4. That way we can execute them. So the first successful stored program product was UNIVAC, which was introduced by IBM in 1951. Okay, so in 1947 a new stored program electronic computer was developed by Institute of Advanced Studies. So it was basically based on, as I told you, Von Neumann architecture. So IAS was one of the architecture systems or concepts using which store program facility was provided. So it also reduced the size of the computer as compared to earlier systems. They were able to provide you 30 different types of instructions, and the word size was increased to 40 bits. Okay, so earlier systems were having earlier versions of the system. Just now we have seen earlier versions of the computers were having a less bit size like 6 or 8, but later on they improved that to 40 bits, and they were also able to do parallel processing also, right? So indirectly they have also introduced the instruction set. Okay, for example, initially I need to give 4 variables and 1 operand, and 4 operands and 1 opcode. Now I am able to provide 1 opcode and 1 operand itself. Okay, so single variable kind of instruction set, that is called as one addressed instruction set, was introduced. Okay, for example, if I want to add 2 numbers, one number I will store on the accumulator and another number I will store in X variable or register, and add X will add the value of X to the accumulator and store the results on the accumulator itself. So it was quite convenient kind of instruction set that was introduced. What were the main features of first generation? Vacuum tube technology was introduced, as I told you. It was unreliable because if a vacuum tube is damaged, I need to replace the vacuum tube with another vacuum tube, and whatever the data is stored inside that vacuum tube was destroyed. So it was very unreliable during those situations. Okay, it supported machine languages only. We cannot write programs in English language or higher level language. So that was one of the disadvantages. It was very costly. The equipments were very cost in nature. That's why most of the military applications or universities were used to implement these systems. Okay, so as there were vacuum tubes and the architecture was very huge, it used to generate a lot of heat, and speed was very slow of the inputs and output devices during those days. Okay, as I talked just now, the size was very huge of the system. Another thing was, in order to maintain a temperature, there was a compulsion need of air conditions so that it can maintain the temperature of the vacuum tubes and the equipments, so that there should not be a lot of heat to be transferred outside. Okay, and it was not portable, obviously. It was carrying about 3 floors of the equipment, so it was unable to move somewhere. It used to consume a lot of electricity also. Okay, some of the generation examples are ENIVAC, EDVAC, UNIVAC, and IBM 650 and 701 are one of the early generation computers. And now let's talk about the second generation. The second generation was made up of transistors. So transistors were introduced. Sorry for title missing over here. So transistors were introduced, and magnetic core memories and magnetic drum storage systems were used, which were faster than magnetic tapes. Okay, and slowly they started introducing programming languages like Fortran and COBOL. Okay, those were one of the new intermediate languages which were introduced in second generation. System programs like compilers were used in order to convert this intermediate level language into lower level language, and concepts like stack, call, and return were introduced inside computers. Okay. Separate I/O processors were developed in order to provide a parallel processing in order to support the central processor. Okay, and during those days, as IBM was one of the companies who implemented first generation computers, so it became a major computer manufacturer during that time in producing computers. So you can see a size from 3 floor has been reduced to a 1 table kind of size, right? So that was all possible due to transistors. Instead of vacuum tubes, they were replaced, and the size was tremendously reduced. Okay, so as compared to first generation, the system was very reliable. It has a smaller size. It used to generate less heat as compared to first generation, and it used to consume less electricity, and it was bit faster than that. Okay, so that was one of the comparisons of first generations. But still, if you compare with latest generations, it was very costly as compared to the current generations. The air condition was still required, and it only supports machine languages and assembly languages, as we have talked about, called as COBOL and Fortran. Okay, some of the versions of the first generation, second generation was IBM 1620, IBM 7094, CDC 1604, and CDC 3600. Okay, one of the UNIVAC was also introduced, which was 1108 kind of model. Okay, these were second generation systems. Now let's move on for third generation. Third generation came into existence from 1965 to 1971, where the transistors were implemented on a single chip. So single chip technology, called as integrated circuit technology, has came into existence, and it replaced the transistors. More higher level languages were introduced, like Fortran 2 to 4. COBOL was improved, Pascal was one of the introduced language, and BASIC was one of those. Okay, now in this generation, softwares were compatible. Some softwares were provided where I can install the softwares and I can use them. And also main implementation or advancement of third generation was parallelism and pipelining concepts were introduced, and also microprogramming concept was introduced, where I'm able to provide parallel execution of different programs. And in order to speed up these executions, cache memory and virtual memories were introduced, where the CPU was able to perform more better way as compared to previous generations. Now you can see that third generation is similar to somewhat systems that we see nowadays. So integrated circuits were used. It was more reliable. It was very small in size as compared to previous generations. It used to generate less heat. It was faster in sense. Okay, less maintenance because the equipments were reliable. Still it was much more costlier as compared to nowadays systems. Still AC was required in order to keep them cool and working them perfectly, and it also consumes lesser electricity as compared to previous generations. Okay, higher level languages were introduced, where just now we have seen more higher level languages were introduced. Some of the generation systems are listed over here: IBM 360 series, IBM 370, PDP, Honeywell, and TDC 316 was one of the models those were introduced that time. Let's move on for the fourth one. Now, the fourth generation started from 1971 to 1980. The fourth generation computers came into existence when they improved from large scale integration, which was in third generation, to very large scale integrated circuits, and near about 5,000 transistors can be inside a single chip. So as the time passed on, the single chip was able to accumulate thousands of transistors. Okay, more higher levels languages were introduced, which we can say we are familiar with: C, C++, and DBase was one of the database related language. So those were introduced during the fourth generation. The concepts like concurrency, pipelining, cache memories, virtual memories were evolved much more as compared to previous generation, hence increasing a lot of performance in the computers. So these are like early stage of your systems. Like we can say fourth generation consists of Pentium computers of Intel. Okay, where they were providing much of the concepts. Okay, you can see the image of a computer which was of Cray 1 supercomputer was made by US. That was one of them, and DEC 10, PDP 11 are one of the main features of fourth generation. So VLSI technology was introduced. Again, systems were very cheap as compared to previous generations. Now those were portable. I can take the system at different places. I can shift it. Okay, I can portably take it in different rooms. Now you can say that people were started using them as a personal computers. Size was very small as compared to previous generations. Pipelining was introduced. This system doesn't require any air conditioning system, and networking was introduced in this kind of generation. Okay, so many people started using them from fourth generation. Now at the last is the fifth generation, that is to be considered from 1980 to till that. Those were integrated with ultra large scale integration technologies. So more transistors were able to be placed inside a microchip. Okay, so many languages have been introduced: Java, .NET, Android, we can say. Whatever the languages you use nowadays, Python language, that is a part of a fifth generation. Okay. These are much more advanced and faster than previous generations. Alright, we have able to introduce artificial intelligence. We are able to introduce natural language processing. We came up with augmented reality, virtual reality kind of concepts. Okay, the systems have become more user friendly. You can say that IoT has come into existence, and we are able to speak with our systems. They are user friendly. They have good graphical textures where they provide information very easily using images, right? So that was the improvement. More advanced technology was implemented, and powerful and compact kind of systems were coming into existence. And obviously, as compared to previous generations, the rates were cheaper of these systems. You can say that the examples of the systems are like computers are like desktop, laptops, notebooks are there. Okay, Chromebooks. Okay, we say ThinkPads, right? So those are many applications or examples of whatever the laptops you see these days. Those come into category of fifth generation. So that is all with the different generations of computers. This was a very basic kind of touch-up kind of session. We will move on further and try to understand more deeper related to computers, how it works out, how the organization goes on inside the computer. Okay, till then, thank you so much. Good day.